Alright, so here we have a problem. We're trying to analyze how much we breathe in, how much air we're breathing in. So the first thing it's asking is about how much N2 we're breathing in. So it starts off, we know that we're looking at 0.65 grams of air. That's how much we're breathing in per breath. And of that, 76.7% is nitrogen gas. And this is by mass. So what we want to do is get exchange rate for this. So what this represents is that for every 100 grams of air, there is 76.7 grams of it is N2. And that's really all we have to do as a percent. So that will convert to grams of N2. And then we want to get to moles of N2. So we know that there are 28.02 grams of N2 in 1 mole of N2. And then we're just going to multiply that out to get our answer. And that will tell us how many moles of N2 we have. So 0.65 times this. And we get about 0.0178 moles, rounding a little bit here, of N2. Alright, so now oxygen, very similar. Again, we're breathing in the same amount of air, 0.65 grams of air. And for every 100 grams of air, there are, in this case, 23.3 grams of O2. And now we want to get this to molecules, so you could do this in one step or you could do this in two. If you prefer to do it in two, we know that for every 32 grams of O2, there's 1 mole of O2. Now you could also just put the 6.02 up here because that is equivalent to a mole. But if you want to see it all written out, every 1 mole of O2 is 6.02 times 10 to the 23rd molecules of O2. So a mole of O2 will tell us that many molecules. So I'm just going to multiply this out again, just like before. Times 6.02 times 10 to the 23rd. So I get 2.85 times 10 to the 21st molecules of O2, which is quite a lot. That's that. Alright, so I want to know the total atoms I'm inhaling. So I know how many molecules of O2 I'm inhaling. I don't quite know how many moles of N2 I'm inhaling yet. So let's finish that. So how much N2 am I breathing in? So 0.0178 moles of N2. Then every 1 mole of N2 is 6.02 times 10 to the 23rd molecules of N2. So 0.0178 times 6.02 times 10 to the 23rd. So that becomes 1.07 times 10 to the 22nd molecules of O2. So we know how many molecules of O2 and how many molecules of N2 we're breathing in. And here's the thing, every molecule, so N2 consists of 2 nitrogen atoms stuck together. O2 consists of 2 oxygen atoms stuck together. So for every molecule you breathe in, you're really breathing in 2 atoms. So we're going to have to double each of these. So 2.85 times 10 to the 21st molecules of O2 is really twice as many atoms of O2. So if I double that number, I get that as far as the oxygen atoms I'm breathing in about 5.7 times 10 to the 21 O atoms. And then for the nitrogen atoms I'm breathing in, well, that's how many molecules. So if I double that, I'm getting about 2.14 times 10 to the 22 N atoms. Notice there's a lot more nitrogen than oxygen because there's a much larger percentage of nitrogen than oxygen, and they're both similar mass. But now I just add those together. So 2.14 times 10 to the 22nd plus 5.7 times 10 to the 21st, and I get about 2.71 times 10 to the 22nd atoms total. Now this is a lot of stuff. We don't usually get asked about the atoms, but that's just sort of, I don't know, just a little more interesting, a little more detail. So one breath, we're breathing in about that many atoms. A real lot of atoms. So, until next time, I am Derek Genova. Have a delightful day.